Hi there, it's another look at kinematics, which basically last time we looked at was 19C.1, which was how to use differentiation to go along this route from X to V to A. And today, as I hinted at last time, we're going to go the backwards version. We're going to integrate instead. And one takes us one way, the other takes us the other way. So if we just have a look at a couple of examples. So before we get going with this is another chance for us to just practice some of our work with differentiation and integration and stuff. So find the equation of the curve of gradient function. Well, notice this has already been differentiated. It says f dash equals. So you should remember that to get rid of the f dash so that we get f of x, you have to integrate. So it's the integral of minus a half x dx. And when I do this, I'm going to add a power, which is x squared, and I'm going to divide by that 2 from the squared. But I've already got a 2 on the bottom, so it becomes minus a quarter x squared. Don't forget to write plus c. Now, it does tell me that f of 2 equals minus 2. So I can let's rewrite this f of x equals minus a quarter x squared plus c. And it tells me if I put minus 2 into here, sorry, 2 into here, my answer is minus 2. So therefore, f of 2 equals minus a quarter of 2 squared plus a constant. And that equals minus 2. Now, 2 squared is 4. A quarter of 4 is 1, so that's really like minus 1 plus c. Minus 2. C equals, I think, minus 1. So therefore I suppose f of x was minus a quarter x squared plus c. It's minus a quarter x squared minus 1. Well, I've written it differently, but yes, the same thing. Notice that those two things are the same. Next one, exactly the same it looks like to me. It says dy by dx equals, so I'm going to want to get y equals. The very first thing I think I need to do is multiply out these brackets. And if you do that, I think you get x squared plus 3x plus 2. You have to do that before you start. And y then is therefore the integral of this thing integrated, because we want to get rid of that. And if I integrate that, I think I get x cubed over 3 plus 3x squared over 2 plus 2x, don't forget a plus c, and write y equals at the front. Now what's it gives me? It says it's passing through the point 2, 1, of course x is 2, y is 1, so let's sub those in. So I get 1 equals 2 cubed over 3 plus 3 times 2 squared over 2 plus 2 times 2 plus c. So what's that? 1 equals 8/3 plus 6 plus 4 plus c. I'm just going to do that on my calculator. I might as well. I don't want to make a silly mistake. So I've got 8/3 plus 10 effectively. And I'm going to do 1 minus that answer when I move it over. I get c equals to minus 35 over 3, which isn't very nice, is it? That would give me an equation that says y equals x cubed over 3 plus 3x squared over 2 plus 2x minus 35 over 3. Let's see if that's right. Yes, that's perfect. So there's our little start. That's a reminder of what integration is all about. We have previously seen these two rules, and hopefully you wrote those down last time. Make sure you do so now if you haven't done so. But today we're doing the reverse of that, and it basically says if ever I want to get x, I integrate v with respect to t. Notice before I said v is dx by dt. You can almost think of this as moving over, and it becomes an integration. Okay. Here again, I said that a is dv by dt. If I move that over, then v is the integral of a dt. Write those two things down. And you might want to draw this picture again, which we saw on the first slide. To move to the left, we differentiate x, v, a. To move to the right, sorry, I think I said that wrong. To move to the right, we differentiate x v. A to move to the left, we integrate a v x. And don't forget, when you do integration, to add the plus c. That is critical. You do need that plus c. Here's a question for us then. The train is decelerating such that a equals that. Find expressions for the velocity and the displacement, given the fact that a is initially 48 and displacement is initially 0. Okay, so I'm just going to start here. I might have to go on to the next slide. So a equals this. We should now know that integral of that, if I integrate this rather horrible expression, 125 t squared minus 6 over 25 of t, if I integrate that, I will get v. And that's the crucial step, I suppose, here. Let's do that. Add a power, t cubed divided by that. So that's 1 over 375 t cubed. Add a power here, that's 6. Well, it's really 6 over 50, I suppose. So the only problem with 6 over 50 is it's better written as 3 over 25. So I'm going to write it as the simplified version. 3 over 25 plus a constant. Now it did tell me, by the way, that the velocity is initially 48. I'll look out for that. Initially, when t is 0, v equals 48. That's what you take from that statement. So if I substitute this in, therefore v equals 48 when this is 0. Now look, the great thing about 0 is that disappears, I'm left with c. And effectively it tells me what my c is. I therefore have an expression for v. It's 1 over 375 t cubed minus 3 over 25 t squared plus the c, which is 48. Then it says also find an expression for the displacement, so I'm going to have to do the same thing again. So just remember that. I suppose the key now is to try and find x. X is the integral of this v. So you can say I wrote it down and ready for this. And now I have to integrate this again. And you'll get very good at integrating if you have to do these questions. Add a power, it's now t to the 4, so I've got to now divide by that 4. So I've got 375 times 4, I might as well do that in the calculator. It's 1 over 1500, there you go. T to the 4 minus, now we've got to put a 3 here, so that goes 3 over 75, or if you like 1 over 25. At least they're cancelling those ones. 48 becomes 48. T plus a new constant, this is what x is. Now it did say what the initially displacement was 0. Alright, so if you put 0 into this, so x is 0 when t is 0. And the reason why that's so nice is therefore c equals 0 as well. All that cancels and c equals 0. And so x is simply 1 over 1500 t to the 4 minus 1 over 25 t cubed plus 48t. Now, what's my third one? Hence find how fast the train is moving and how far it has moved after 30 seconds. Well, basically, it's sub in 30 into my expressions for v. So I'm going to write this here when t equals 30. I think it said 30. Yes, it did. Oops. V equals, now I can just put 30 into this, so I shall do this now. 1 divided by 375 times by 30 cubed minus 3 divided by 25 times by 30 squared plus a 48. 12, wow, that's a very nice answer considering. So initially it's 12. So t, when t is 30, v is 12. How far, I think it's what its displacement was as well, so I shall do that. That's 1 divided by 1500 times by 30 to the power of 4 minus 1 divided by 25 times by 30 to the power of 3 plus 48 times 30. I get 900. It's got 900 meters. 912. Look at that. They're both of those work. A car is moving with velocity vt equals 15 plus 5 root t. Well, straight away, I don't like this particularly. V equals 15. plus 5t to the half. Much easier. And it says find the acceleration of the car when t is 4. Now just remind yourself, remember the x, v, a. And if you go this way, you're going to differentiate. And I think we are differentiating. We've got v, we want a. So therefore a equals, I'm going to differentiate this. 15 will disappear. Half moves to the front. 2.5, lose power, minus a half. It says do this when t is 4. So I can just sub it in. I'm going to squeeze it in there. So it's 2.5 times by 4 to the power of negative 0.5. Now negative 0.5 is actually that's 1 over the square root of, so it should be quite nice. Yes, the answer is 5 over 4. Or 1.25, I suppose, meters per second squared. So that was the first part of this question. And then there's another one that says use definite integration to find a distance travelled by the car between t equals 2 and t equals 10. So it highlights the fact that if you want an area, a distance travelled between 2 times, you can, for instance, here just do the integral between 2 and 10. This is going to be my distance travelled. And of course, to find the distance travelled, I can just go backwards. That's like the displacement, but if I want a distance travelled between 2 times, you can just do it as an integration between these 2 times. Notice I've got my v already. That's 15 plus 5t to the half. And so what I've got to do is integrate. So this is a question, and a good example of this is where in exam questions it's very common for them to give us the v. Because then you've got the choice of, are you going to go this way, and I'm going to have to integrate, or am I going to go this way, in which case I'm going to differentiate. So they like the fact that you can go both ways. Sometimes they give you x and they make you differentiate twice. Sometimes they give you a and you have to integrate twice. But anyway, let's integrate this anyway. So it's so this is going to go 15t plus, and I've got to do 5 divided by, well, effectively 3 over 2. So I think that's 10 over 3 when you do that. Check that for me. 3 over 2 between 2 and 10. So I can substitute 10 in, and I can substitute 2 in, and I will get, let's just see, so if I substitute 10 in, I get 150 plus 10 thirds. I'm going to have to do this in my calculator. 10 thirds times by 10 to the power of 3 over 2. That doesn't look a very nice answer to me. Oh, no, it's not. That says to me 105.4. I'll do 4-1. And I do exactly the same thing. I'll put 2 in, which is 30. Yeah, so I've got 10 thirds times 2 to the power 3 over 2. And I get 9.43 there. 4, 3, yeah, that's probably enough. So effectively I've got 255.41 minus 39.43, and it sounds just over 200 odd. So 255.41 minus 39.43, and I get 215. Well, to 3 6 fig, that's 216 meters. Is it meters? Yes, it is. So there's my answer. And 216 meters is right. So look, that's the end of that. We've now had 2 goes at this. We've looked at this initially in 19C.1, and now we've done 19C.2. This one was differentiation, and now we're doing integration. Before I move on, just be aware you could have used the posh button on your calculator. There is a button on your calculator that looks like this. And we could have, I suppose, cheated. We could have typed into here on that last question. The question said, if you recall, 15 plus 5t to the half. So we could have quite easily typed into that 15 plus 5t to the half. Get my pen back. 15 plus 5t to the half. We could have put 2 into this box, we could have put 10 into this box, and just press equals. The only reason we couldn't do that was actually it said use definite integration. Sometimes they say use detailed reasoning. But if they didn't, we could have cheated and let the calculator do it. But anyway, we'll worry about that more in class. In class, we'll do exercise 19C to the end this time. Cheers.